Imagine a world where cars drive themselves, devices talk to us, and entertainment platforms know our tastes better than we do. It might sound like a scene from a sci-fi movie, but this is the reality we're living in today. Welcome to the AI revolution. Artificial intelligence, or AI as it's often called, is no longer a futuristic concept. It's here, and it's transforming the world around us in ways we could have only dreamed of a few decades ago. If you've ever used a virtual assistant like Alexa or Siri, hailed a self-driving car, or marveled at how Netflix always seems to know what you want to watch next, then you've experienced AI in action. These are not isolated examples. AI is everywhere. It's in the smartphones we can't live without, the cars we drive, the entertainment we consume, even in the way we shop and do business. It's not just making our lives easier, it's changing the way we live, work, and play. But how does it all work? How does a machine learn to drive a car, understand human speech, or predict what movie you'll want to watch next? The answer is artificial intelligence. But what exactly is AI? Is it just a bunch of fancy algorithms, or is there more to it? AI is a broad field that encompasses many different technologies, including machine learning, neural networks, and deep learning. These technologies enable machines to learn from experience, understand complex patterns, make decisions, and even predict future events. They're the reason why your smartphone can recognize your face, your car can navigate busy city streets, and your favorite streaming platform can recommend the perfect movie for a lazy Sunday afternoon. So what exactly is AI, and how does it make all these amazing things possible? Prepare to have your mind blown as we delve into the fascinating world of artificial intelligence. We're going to unravel this mystery, one concept at a time, and by the end you'll have a clear understanding of what AI is, how it works, and why it's such a game changer. Let's get started. In simple terms, artificial intelligence is all about computers simulating human intelligence processes. But let's break that down a bit further. Essentially, we're talking about creating a set of instructions, or as we like to call them, algorithms. These algorithms allow computers to perform tasks that would usually require human intelligence. We're talking about tasks such as learning, reasoning, perceiving, inferring, communicating, and making decisions. Now, you might be wondering, how can a machine possibly learn or reason? Well, that's the magic of artificial intelligence. It's not about computers becoming sentient beings, but rather about them having the capacity to process information in a way that mimics human intelligence. Imagine you're teaching a child to recognize a cat. You'd probably show them several pictures of cats, explaining each time, "This is a cat." After a while, the child starts to recognize cats on their own, without needing you to point them out. That's because they've learned to recognize the common features of cats: the whiskers, the pointy ears, the tail, and so on. In a similar way, we can teach computers to recognize cats, or to do any other task that requires understanding and analyzing information. We feed them a lot of data, and we design algorithms that allow them to process that data, identify patterns, and make decisions based on those patterns. But here's the kicker: unlike the child, who might get bored after seeing a few dozen pictures of cats, a computer can process millions or even billions of pieces of data in a relatively short amount of time. And the more data it processes, the better it gets at recognizing patterns and making accurate predictions. That's the power of artificial intelligence. It's not about replacing human intelligence, but about amplifying it. It's about creating tools that can help us solve complex problems, make informed decisions, and even push the boundaries of what we thought was possible. But how do computers learn? This brings us to our next concept: machine learning. Machine learning is like feeding a newborn with information, allowing it to learn without explicit programming. When we talk about machine learning, it's all about the data, big data to be precise. Imagine a giant buffet of information, and our AI is grabbing a plate and piling it high with data. The more data it consumes, the more it learns about patterns and relationships within that data. It's like teaching a child how to recognize shapes. Show them enough squares, and they'll start to understand what makes a square a square. So how does this work exactly? Well, it's not just about shoveling data into a computer. Machine learning algorithms are the secret sauce that makes this all possible. These algorithms are like a set of instructions for the computer, guiding it on how to analyze the data and learn from it. One of the most common types of machine learning is called supervised learning. Here, we give the computer a set of inputs and the corresponding outputs. It's like teaching a dog to fetch. You show the dog the ball, input, and then you show it what to do, output, which is to bring the ball back. After a while, the dog learns that when you throw a ball, it's supposed to bring it back to you. Another type is unsupervised learning, where we let the computer loose on a dataset without any specific instructions. It's like letting a toddler loose in a playroom. They'll start to figure things out on their own, grouping similar toys together, and learning through their own exploration. Machine learning is a powerful tool, but it's not without its challenges. The quality of the data matters a lot. If you feed the machine bad data, it's going to make bad decisions. It's like the old saying goes, garbage in, garbage out. Machine learning has revolutionized fields from healthcare to finance, enabling us to analyze and predict patterns on a scale that would be impossible for a human to do. But to understand how machine learning can be so effective, we need to delve into the concept of neural networks. Neural networks are software constructs that mimic the human brain's neural pathways, enabling machines to think like us. Imagine your brain, a complex network of billions of neurons, each one connected to thousands of others, forming a vast, intricate web. This is the model for neural networks, the backbone of artificial intelligence. Neural networks are like digital versions of our brains. They're composed of nodes or artificial neurons arranged in layers. There's an input layer where the network receives data, one or more hidden layers where the processing happens, and an output layer where the final result is produced. Each node is connected to others, with links that transmit data from one node to the next. These connections aren't just simple pathways though, they're weighted, meaning that some connections are stronger, more influential than others, just like in the human brain. When data enters the network, it doesn't travel on a straight line, it gets passed around with each node processing a small part of the information. The nodes weigh the incoming data, apply a function to it, then pass it on to the next layer. But here's where it gets really interesting. Neural networks learn by adjusting those weights. They start out with random values, but as the network is trained with more data, it begins to recognize patterns. It adjusts those weights, strengthening some connections and weakening others based on what it learns. This process is called backpropagation. So think of a neural network as a team of learners, all collaborating to solve a problem. Each learner handles a small part of the problem, but together they can tackle complex tasks. It's this ability to learn and adapt, to process and understand data in ways that mimic human cognition, that makes neural networks so crucial to artificial intelligence. It's like teaching a child to recognize objects. You don't program them with explicit rules. Instead, you show them examples, and they learn over time. Neural networks do the same, learning from examples, adjusting, and improving their understanding with each new piece of data. Now that we know about neural networks, let's delve deeper into a more complex concept: deep learning. Deep learning is a complex neural network with many layers that processes data in powerful new ways. Now, let's break this down. Imagine the human brain, with countless neurons firing and making connections. Deep learning emulates this process, but with an intricate web of artificial neurons, each processing a piece of information. This web, or network, can have hundreds or even thousands of layers, each adding depth to the learning process. The beauty of deep learning lies in its ability to learn from unstructured data. Think images, audio, text. It can recognize patterns, interpret context, and even make predictions. This is the engine behind your favorite voice assistants understanding your commands, or the uncanny accuracy of your social media feed recommendations. Deep learning is no less than the future of AI. It's set to revolutionize industries, from healthcare, where it can assist in diagnosing diseases, to transportation, where it powers self-driving cars. AI has a massive transformative potential across various industries. From robots to finance, from medicine to transportation, AI has the potential to innovate and revolutionize. We've journeyed together through the world of artificial intelligence, exploring its key concepts: machine learning, neural networks, and deep learning. These are the gears and cogs of this transformative technology, powering everything from self-driving cars to virtual assistants. As we look forward, we can see an exciting landscape. AI has the potential to reshape our world, driving innovation and efficiency across industries. But like any powerful tool, it also carries risks. Privacy, job displacement, and ethical dilemmas are challenges we must confront as we navigate this brave new world. Yet despite these challenges, the future of AI is bright. It promises to enhance our lives, solve complex problems, and open new frontiers in science and technology. The future of AI holds great promise, and like any powerful tool, great responsibility. But one thing is certain: AI is here to stay, and will make the world a better place.